Now that you got to know about what the register is, then let's talk about how to learn about the register effectively. This is a very good question before you start to learn about the register, because having the effective way to learn about the new subject is also important. The first thing you have to keep in mind is that we need to understand the basic principle of the register. And for understanding this principle, we need to refer to the reference manual of Armv8-A data architecture. If you refer to the document that is written by Arm companies, you're going to see how the general purpose registers are organized, how the system register is organized. So it is necessary to review the Arm reference manual. Arm reference manual describes how registers are actually used using the sample code. So first step is to read the Armv8-A manual. That is the important step. So for better understanding, let's look at the sample, the source of Arm reference manual. As you can see, the Arm reference manual describes how the registers are organized. In this case, the Arm reference manual describes special registers in Armv8-A data architecture. As you can see, in each exception level, there are SP-EL1 register, SPSR-EL1 register, ELR-EL1 register. So it is necessary to read and review the contents of Arm reference manual. This material will be thoroughly reviewed in the later lecture. Then this is another example of Arm reference manual, and this describes the bit assignment map for SPSR-EL1 register. As you can see, the bit assignment map describes how the specific bit field represents the operation of the specific feature. In this case, exception level is contained in 0 to 30 bit. And as for exception bit mask can be controlled and written in this bit flag. So analyzing this kind of Arm reference manual is the first step to understand how the register are organized, how the register are structured. Once you understand the basic principle of the register, the next important step is to perform debugging. So Arm companies provide several Arm simulator. So if you make use of Arm simulator to run the assembly instruction, GDB is the widely used open source based debugger. If you run GDB debugger, you're going to run any assembly instruction by looking at the value of the general purpose register. And another popular hardware debugger is trace-reto, the hardware debugger. So if you have a chance to run the trace-reto debugging program, you have the good chance to run any of the assembly instruction to see how the register is updated. So now that if you perform the debugging to run assembly instruction to see how the register is updated, next step is to understand the calling convention. The calling convention is important to figure out how the general purpose register is used. In the Armv8 architecture, the stack pointer SP register, X30 register are used to contain stack pointer of the address of the process, and X30 register is used as the link register. The X0 to X7 register is used as the argument register in Armv8 architecture. So if you understand the calling convention, you will going to see that assembly block is organized based on specific pattern. That is, in the beginning of the subroutine, you're going to see the sort of the pattern. That is to push the value of x30 register on the stack area, and then you will copy the argument register from x0 to x1, x3 register, because argument is passed using this kind of argument register. As for function call, before BL assembly instruction, you're going to see that x0 register, x1 register, x2 register are manipulated by running add or sub-assembly instruction. So in order to see those kind of patterns, I believe that understanding the calling convention is essential. So once you understand the calling convention, next important step is to have the code review. If you refer to the starter code, you're going to see that the necessary system registers are configured, such as VVAR ER1 register and TT-VAR ER1 register. Those system registers should be configured in the starter code. So as you know, U-boot bootloader is popular in practice, and Linux kernel is another widely used, popular substack. So it is recommended to you to have the code review about starter code in U-boot or Linux kernel. Now let's summarize what I have discussed so far about how to run about the register in effective way. The first thing is you need to refer to the ARM reference manual. The second step is to perform debug practice using GDB debugger or ARM simulator or 332 JTAG debugger. And next step is to understand the calling convention. If you understand calling convention in the Armv8-A architecture, you're going to see the sort of the patterns in the assembly block. And the last thing is have the code review over starter code in U-boot or Linux kernel. Now that you understand the effective way to run about the register, the next lecture we will explore the type of register in Armv8-A architecture.